All right, guys. The previous class, we touched on the topics of properties of logarithms, right? That topic. And the idea was we are going to get ready to the big one, the one that we are all waiting for, logarithmic equations. How do we find the value of x, right? That
Profe,
makes it so
¿todavía
that,
no está el quiz?
Danny, what? Yes?
¿Todavía no es el quiz o...?
No, no, we're not gonna do the quiz today. We're gonna practice this topic today, and the next class we're gonna do the quiz, Danny.
Wait, no, no, I mean the class works today of Moodle.
We are
Of
gonna have a
Alex, of
classwork
Alex,
today.
of
Yes,
Alex.
yes, we are gonna have a classwork, not a
Uh,
quiz, but a classwork. Yes. Remember, classworks you can do them several times, right? You can do classwork several times and ask questions and all of that. So it's a little bit easier than a quiz, because a quiz you're on your own, right? All right. So as I was saying, how do we find the value of x that makes it so that everything to the right or to the left of this equation is the same as everything to the right? How? What is the value that we put here in x so that this equals 3? How? Instead of changing values or guessing, instead of guessing values, we can do a process. And that is exactly what we are going to do today. And the best way is with an example. So, first step, we're going to take the question, and we recognize from here that we can, simply because there is a logarithm on one side and there is not another logarithm on the other side of the equation, right? Look at that. There is a logarithm here in the left, and on the right, there is not a logarithm. It's just a tree. Simply because of that, we can try to change this into something that we are more comfortable working with. I don't know about you guys, but logarithms, they are difficult for me. But you know what is not difficult? Exponentials. Powers are not difficult. I can work with powers all day long because I know the properties of those. So what I'm going to do is change this logarithmic expression into an exponential one. That's it. We're going to change it. I don't know if you guys remember how, but it is this easy. The logarithm base 2, right? I'm going to remove it, and I'm going to pass this 2 to the other side. The 2 is going to go as the base of the exponent. So here it is. There it is. There it is, guys. Ha. Now, we no longer have a logarithm base 2. No, 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 no. Now the 2 is the base of the exponent. And now we have an exponential equation, and this is a little bit easier because we know how much is 2 to the third power. We know how much is that. Everybody in the chat, please.
Teacher, again, where do you can explain again how do we got the 2 to the third? I don't understand.
Sure, Danny, absolutely. Let me just open my tool. This, all right. And I'll be, all right, I'm gonna work with this. So Danny, what we are trying to do is get rid of this logarithm base 2, right? Remember, we are
Yeah.
isolating, right? We are isolating the variable, okay? So if we want to isolate it, we want to take this logarithm base 2 and pass it to the other side, right? But we know, this is what I know, right? We know that logarithms are the inverse, right? So log is the inverse. I have to do a little bit more space here. There. Log is the inverse of exponentials, right? Of powers. Right? We know that, Danny. We know that. So if I move the 2, to the other side, I have to move it with the opposite or the inverse operation. Right?
Wait.
That is why if we move up one that is adding, we move it to the other side to subtract. Or a value that is multiplied, right? a value that is multiplying, we move it to the other side to divide, right? We move it to the inverse operation. And the inverse operation of logarithms is powers. So the result is whatever I had to the left, there it is, right? This is what I had left, right?
Okay, okay.
Right?
Now, thank
And
you.
now the 2, we move it as the power. So it is 2 elevated to the rest on the right. So to the 3.
Thank you, teacher.
You are welcome, Danny. And hey, man, again, keep on asking, all right? Don't worry about it. Keep on asking, and I'm going to keep on helping you. All right, so let's continue with this. Now, we know how much is 2 to the third power. That is something that we do know, right? We do know how much that is. Everybody in the chat, please, right now, tell me, how much is 2 to the third power? All right. Only 4 of you are paying attention, apparently. I want everyone, please, every single one of you. We have 26 people today. I expect 26 answers. Thank you, guys. All right, beautiful. 2 to the third power is 8. So now we can say this is no longer an exponential equation. Look at that. Look at that. By doing this change, by moving the little 2 to the right, this equation got a lot easier, right? How do we isolate the x from here? How? Well, we're going to have to begin by moving the 1. The 1 is adding, right? So we're going to move it to subtract. Look at that. The 1 passes to subtract, right? So we have 8 minus 1. That's a 7. All right. What do I do about this negative 2 here? Well, the negative 2 is multiplying, right? If I want to move it, I'm going to have to move it to divide. Result then, x equals negative 7 over 2 because of the negative, right? Negative 7 over 2. Negative 7 halves. If you are a fan of decimals, this is negative 3.5. Beautiful. Now we know the value of x that makes this whole logarithm equals 3. Okay, all right. All right. Pretty good, huh? Pretty good. All right, guys. This was a simple logarithmic equation, and these are the easiest that you can find. I have a lot of exercises like these planned for you today in your Alex classwork, all right? I have a lot of these, but I also have a lot of other equations. Equations like this one. Take a look at these, guys. Take a look at this equation. The main thing that we should see from the beginning is that to the left, we have a logarithm and also a logarithm to the right. So this is not a process like the previous one. We cannot just move the logarithm in hopes of isolating the variable. We can't, because there are logarithms on both sides. What do we do? Well, luckily for us, both of these logarithms have the same base. They have the same base. So we can do a little trick called canceling the logarithms. But we cannot do it right now. No. And you know what? Because of this little 2 here. This 2 is multiplying. So I cannot cancel the logarithms. Otherwise, what do I do with the 2? What do we do with that 2? No. But this is the process we are going to do. Solution. First, we're going to write the equation again. And from here, we're going to notice that, again, since the 2 is multiplying a logarithm, I can apply one of the properties. The property where I move the factor of the logarithm, right, the multiplication, and move it as an exponent. Take a look at this. Boop. There it is. There it is. The little 2 is now an exponent. That is one of the properties. And now I have logarithm in front of the value to the right and a logarithm in front of the value to the left on both sides, right? Now we can cancel the logarithms. This is a process or a trick that you can do. But again, the only thing on the left has to be a logarithm, and the only thing on the right has to be another logarithm. And both have to have the same base, just like in this example. Now, if I cancel the logarithms, I am going to be left with the rest. There it is, the rest. X squared equals 9. So now, this logarithmic equation has no longer any logarithms. It doesn't have any logarithms now. It doesn't have any logarithms now. What it does have is a quadratic equation. X squared equals 9. A quadratic equation. Now, you can solve this by factorizing, or you can solve this by doing the, how do you call it, the quadratic formula, right? You can do those. Why don't we just move the little 2? Look, that 2 is an exponent, right? If I want to move the exponent, I pass it as a root. So x equals the square root of 9. But 9 has 2 roots, positive 3 and negative 3. So there it is. There it is, guys. There it is. There it is. This equation had 2 possible solutions, 3 or negative 3. Both of those are equally correct. All right. Okay. Pretty simple, huh? Pretty simple. But what if I give you one that is a little bit more entertaining? How about this? How about these guys? Huh? This is an example different to the previous 2, where on the right, we don't have a logarithm, but on the left, we have 2. In fact, these 2 logarithms are adding. Man, what do we do? If we only had one logarithm here, then we can simply pass it, right, to the other side as a power. But in this case, we have 2. We have 2 logarithms. What do we do? Any ideas? In the chat, please tell me. Can you think on any ideas, any possible solutions from here?
Can I say it?
Sure.
Maybe combine both because they have the same base.
Tefa, you are the best. Thank you. Yes, look at this. They have the same base, right? Base 5, base 5. And right in the middle, we have an addition. So that means these 2 logarithms have the 2 conditions that we need for us to combine these 2. The 2 logarithms that we need so that we can combine them. Okay. All right, okay. Let's do that then. Solution. First step, let's copy the equation again. Second step, combine them, right? So we know the logarithm has to have the same base, right? There it is. And the resulting, or the inside the logarithm, I am going to multiply the 2 values. So x plus 6 times, right, multiplied by the second value, x plus 2. There it is. From here, now that we only have one logarithm, now we can move it to the other side to isolate the variables. If we move this 5, we're going to move it to the other side as a power. So the base 5 becomes the base of the power. There it is. We are left with x plus 6 times x plus 2. This is the rest of the left. And on the right, we have 5 times, 5 elevated to the first power, which is just 5. What do we do now? Well, now this is a quadratic equation. We can expand these, right? So multiply these 2 factors. X times x, x squared, right? We're going to do the FOIL process, remember? Firsts, xx. O of outer, so x times 2, right? Then the inners, 6 times x. That is 6x, right? So 6x times 2x, or plus 2x, sorry. That is 8x, right? And then the outers, so 6 times 2, 12. This is the amplification of these two. This is the result after we did the FOIL process. Of course, to the right, we have just the 5 alone. From here, we are going to solve this as this was a quadratic equation, and that is because it is a quadratic equation. Did you guys remember how to solve quadratic equations? Guys, do you remember or not? All right, what happened with this?
Not teacher. I do not much remember.
All right, don't worry. Don't worry. You don't have to remember then. Don't worry. I'll do the review for you. I'll do a review for you. The first step is equal this equation to 0. That is the first step. Make it equal to 0. To do that, we're going to have to pass the 5 to subtract, right? The 5 is positive, so we move it to the left to subtract. So that is 12 minus 5, which is 7. All right? So now the equation equals 0. Now that it equals 0, now we can apply the quadratic formula. Or we can try to factorize this. Is this factorizable? Is that how can we factor this equation? This expression, can we factor it or not? We're looking for two values that when added gives you 8 and when multiplied gives you 7. Can you think of two? Both values are positive. Can you think of these two or not? In the chat, please tell me. What are the two values? When you add them, it gives you 8. And when you multiply them, it gives you 7. All right. Thank you, guys. Thank you. Thanks to the three of you who actually get the answer. Beautiful. 7 and 1. Yes. Or you can also say 1 and 7. It doesn't really matter, right? So here it is. We can factorize this equation. X plus 7, the first factor. X plus 1, the second factor. These are the two values, 7 and 1. 7 plus 1 equals 8. 7 times 1 equals 7. So yeah, we did it right. And why did we do this process? Why did we factorize like this? Well, because now, since this factorization, this multiplication, remember, factor is the same as multiplication. So this multiplication here equals 0, which means we can open this multiplication. One will be equal to 0, and the other also will be equal to 0, like this. If 1 equals 0, then 7 plus x plus 7 equals 0. From here, x equals negative 7. From the other one, x plus 1 equals 0. So we can pass the 1 to subtract, equals negative 1 then. X equals negative 1. This was another equation where we had two possible solutions. If we replace here, the x here, and also here, by a 7, right? If we replace it on both sides by a 7, the result will be 1. But if we also replace the x by negative 1 on both sides here, by negative 1, sorry, and here by negative 1 as well, the result will also be a 1. Cool, huh? All right. What do we do now? You think you guys are ready for your classwork? I think maybe we can take a look at these. One example with natural logarithms. This is the mother of all. Take a look at these guys. We have natural logarithm on the left, and on the right we have two logarithms. So we cannot just cancel these two. We cannot cancel the two logarithms. What can we do then? Any ideas, guys? Write it in the chat, please.
Teacher, why we can't cancel both?
Here. By
They're
canceling,
both natural logarithm. So
yeah,
logarithm of e.
sure. But look at this, Danny. By canceling, I mean you cannot just do this. You can't.
No, I not meaning that. I mean in the other one.
These two,
Yeah.
you cannot cancel them. Why? I'm gonna tell you why. Because in the middle we have a
Mhm.
subtraction, right? If we have natural logarithm of a value equal another natural logarithm of another value, then we can cancel these two because in the middle we have an equality. Cancellation can only be done if you have equalities. But in the middle, we don't have an equality. We have a subtraction. So we can't. All right? All right, let's take a look at some ideas. Stefa Cabrera is saying combine both in the right side because they are subtracting and they have the same base. Yes! Stefa! Yes! All right. On the right, we have natural logarithm. Danny, cut the mic, please. Thank you. On the right, we have natural logarithm and also natural logarithm. So we have two with the same base. And in between those, we have a subtraction, which means we can combine them into one natural logarithm. That natural logarithm will have a division inside it, right? Here it is, solution. Write the equation again, and combine the logarithms. There it is. The first value is going to go up. The second value is going to go down. In the middle, we have a division, a fractionary. Tefa, you are correct. Pretty good. Pretty good job, Tefa. From here, now we can cancel the logarithms because look, between the two logarithms, we have an equality. We couldn't do it before because we have a subtraction, but now here, we don't have no subtractions now. We only have two logarithms. So we can cancel the logarithms and we are left with the rest. X equals a fraction. The problem now is that what process do we do to isolate the variable? Look, we have the same variable, right, x, but it is everywhere. This x is all over the place, man. The x is on the right, it's on the left, sorry, alone, but it is also to the right as a fractionary on the numerator, and it is also in the denominator. So what do we do? Can we just cancel the x's here, these two? No, not because we have additions and subtractions. If these two x's were alone, then sure, we can cancel them, but we have something else, so we can't. What do we do then? Huh? This equation is beautiful because we began by something that looked easy, but now we are left with something that it doesn't look easy. All right, here is my process. Pay as much attention as you can, please. What I'm going to do is get rid of the fractionary because that fractionary is not something I want to work with. I am going to destroy the fractionary. To do that, I recognize that the thing down, right, the denominator, the down part, the denominator, is dividing the thing up, the numerator. So since the denominator is dividing, I can move it to the other side to multiply. And if I do that, I have this. Now, I no longer have a fractionary. Sure, I have a multiplication here, and I also have x's there. But I can do this multiplication. This multiplication is pretty easy to do. This multiplication is pretty easy to do. Just do x times x and then x times -4, like that. Right? So now we can kind of see that before this quadratic equation, because it is a quadratic root, look, the exponent is 2. This is a quadratic equation. Before this, we had a fractionary. And to be honest, in the fractionary, you don't really know what to do, right? But if we do this process, if we get rid of the denominator and move it as a multiplication, then we can now work with this. This is something workable. Quadratic equations, right? Again, just like in our past exercise, we need to equal this equation to 0. So we are going to move the x to subtract and also the 6. If I move the x to subtract, I'm going to have -4 minus 1x. Right? -4x minus 1x. So that is -5x. There it is. And of course, the 6 was positive, so it is now negative. All right? Again, just like in our previous exercise, we can factorize this equation, right? We are looking for two values that, when added, gives me -5. And when multiplied, the result is -6. What are those two values? One has to be negative, the other one has to be positive. Tell me in the chat, please. Tell me. What do you think those two values are? When I multiply them is 6. When I add them is 5. What? Come on, what?
3 and 2.
3 and 2, all right, let's think about it. 3 and 2. All right. 3 times 2 is 6. Yes, sir. Yes, sir. And 3 times 2, 3 plus 2 is 5. Yes, sir. But we have an issue. As I said at the beginning, one of the values has to be negative and the other one has to be positive. So if we do -3 plus 2, doesn't work. If we do -2 plus 3, right, the other one.
Maybe 6 and 1.
Maybe, all right, maybe 6 and 1. That's a good idea, right? That's a good idea, Danny.
Much people and much people also say that in the chat.
All right,
not
look at
just
that.
me.
You're right. Tefa Cabrera, sorry. Mariana and Nico Parra. All right, thank you guys. -6 and 1. All right, let's see. There it is. There it is. -6 plus 1 gives me -5. And -6 times 1 gives me -6. So this is a good factorization. And from here, we can find the values. Now, 1 is going to have to be 6, right, from here. And the other one, it has to be -1. So there it is. There it is. There it is, guys. There it is. Take a look at that, guys. Take a look at that. There it is. The two possible solutions from our equation. So if I replace 6 here in this x, here in this x, and here in this other x, the result to the right will be the same as the left. And if I replace the x's again, here, here, and here, by a -1, the result on the right will have to be the same on the left. Beautiful. We did it, guys. We did it. We did it. And with that, now you guys are ready to work on your classwork. So what I want you to do, please, go to alex.com and work on the classwork that I have planned for you guys there. I'm going to stop the video here. And remember, if you have any doubts, you can always ask. Good luck.